Welcome everyone, hope you're having a great day so far. And well, let's start with introducing you to me, so then at least I know a bit who I'm talking to. Who of you has ever felt when programming, working on a code base like the guy on the left here, the happy one? Please raise your hand. Good. That's good. That's the best feeling. You know right away where you need to be in the code, and it reads like a novel, and all the related parts, you instantly understand that. Now, for that other guy, the guy on the right, who has ever felt like the guy on the right? Yeah, also. Yeah. Maybe some of you today who has felt like the... okay, a few today. So let's be extra kind to them when we drink there. So, okay, thanks. Now I know a bit of you. I will return the favor. My name is Jos Roosboom. I'm a freelance software developer. And, well, I've had my days like the happy guy on the left. Also like that guy on the right, and that guy on the right is totally the opposite. He has a hard time finding where he needs to be in the code. Code is, well, doesn't read like a novel, more like a puzzle, and related code, yeah, he finds out the weekend after it's deployed to production that there is related code. So that's not where you want to be. And if you continue struggling like that right guy, it might climax into this. Some kind of exploded brain. And well, 1 year ago I was working at monoliths, which is an American company creating software for fundraising, and we as monoliths developers felt more and more like that guy over there. When we needed to change our code, we felt that more information was needed to put in our head than we could comfortably host there, resulting in, well, some kind of StackOverflow. So a brain explosion, like the guy over there. And obviously that's not nice. It makes you frustrated. You make more bugs, it takes you longer to accomplish a task. So we decided to fix that problem. And today I will tell you about the problem we run into, the solution we picked, and how Spring Modulith helped us with that. So to start with the problem, we felt that the overall structure of our code was not very clear. Now, structure, if you look for structure in the dictionary, it says something like the way we build things from other things. And in Java, we build things, so we can apply that to Java. And if we do that, it kind of looks like this. We have an instruction like C is B plus A, and we group those instructions into methods, we group them into classes, we group them into a package, and that ends up in a jar that, well, we might deploy. All the decisions we make here along the way are important for the overall structure of our code and the clarity of it. But today I will just talk about the package level. So the decision we make to put classes into a package and to put packages in other packages. So the way we nest them. And we all have to make those decisions unless you only have a handful of classes that you can put in the root. So we have to make some kind of structure using packages, and often it's grouped by the role those classes have. So, for example, a controller, a service, a repository, and, well, there are probably other roles as well, like a DTO request or whatever. But the key thing I want to point out here is that we slice it horizontally. So we group them by role. Now, probably there are a lot of classes with the same role, so we have some sub-packaging, and if we do that, then we solve the problem of having a lot of classes in the same package. But we felt that our problem was not solved yet. Because if you look at this diagram, you see the blue arrows here, and they indicate the relations between those components. And it's a mess. And the dashed line here, it's a circular dependency, but even if you don't take that into account, still it looks like a mess. But it makes sense if you think about it, because we have a product controller and that uses a product service. But since they are in different root packages, well, there is a dependency between them. So it's inevitable, this mess. This was the solution we picked. So instead of slicing it horizontally, so initially by the role they have, the classes have, we split them by the feature they represent, or the subject, or bounded context in terms of domain-driven design. Now, you might think, yeah, this is already solved. We had this microservice solution. We have Maven modules, even Jigsaw. I don't know. Is there anyone who uses Jigsaw in his own production code? Here, please raise your hand. No, no one. 2 weeks ago in Arnhem, also no one. And in Amsterdam, it was 1.5 out of 110. So not many people use that. But we could. But the thing here is that they all work on the jar level. So if you look at the structure diagram, it's good that those solutions are there. But also we want something on the package level. Because we could use the jar solutions, but that would be an explosion of artifacts if we used Maven modules. And we can still do that. We can still make multiple modules. But within such a module, it would be nice if we have a proper solution for modularization on the package level. There's only one problem. In Java, we kind of have a lack of force. You can have circular dependency that makes things more complex. The order package can depend on the product package depends on the order package. Java compiler says, go ahead, no problem. Access restriction, well, the compiler offers a bit of help there with package private. So if you omit the public keyword for a class, then only that class can be used in its own package. But let's do a quick raise of hands. If you create a new class in your IntelliJ, public class, blah, 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 who of you thinks a bit of time if that public keyword can be removed? Who does that? Okay. Some of you, and a half. That's also good. I always like if such a vote ends up in and a half. So I will only remember the half. That's very good. And if you can do that, then the Java compiler will help you. You don't need any other help. Just omit the keyword. But if you design your class to be used from another package, we are a bit out of luck. We have to make it public. But if we make it public, the entire world can use it. And that's where Spring Modulith comes into play. Spring Modulith is a product from Spring. It works with Spring Boot 3 and above. And Modulith is kind of a blend between a monolith and modular. Monolith because we deploy it as a single unit, and it kind of is infamous for turning into a big ball of mud. So that's where the modular part comes into. This project aims to modularize the monolith. Still deployed as a single unit, but modularize it within the monolith. It blocks circular dependencies. It offers way to restrict access, more fine-grained than just your own package or the entire world. And it does so by letting a unit test fail. So we don't have to wait for some deployment pipeline to get the feedback. It fails on our own machine before committing and pushing that. Of course, you have to run your unit test before you commit and push, but then that will work. It's built on Arch units, so if you don't use Spring Boot or don't even use Spring at all, you can still use the IDs of this talk, but then, well, you need a bit more code, and there are some extra goodies in Spring Modulith that you can't use, but still, you could do that. Now, how do I do that? Well, that's a good question. So I will switch to my IntelliJ. And actually, this was the moment that it popped up, do you want to remove it? But my keyboard is 50 kilometers away, and now it's all fine. So I can just show you Spring Modulith, which is better than this quiz of what happens to my computer. Freelancer Finder here is a demo application because, well, I am a freelancer and, well, the world needs to find people like me, of course. So this is really an important demo application. And it's a Spring Boot application. Here you see the entry point of it, which is not very spectacular, but I will show it because of the first definition of Spring Modulith. And that is that a module is a direct subpackage of the root package. And the root package here is the package that hosts the entry point. So here we have the entry point. The root package is com.easyu.freelancer finder. So bidding is a module here in terms of Spring Modulith, as is freelancer, as is review. Review.analysis is an internal package of the review module. Now, a great feature that Spring Modulith has is dynamic generation of documentation just by a unit test. And this unit test here, it collects the modules, application modules, that's just a class from Spring Modulith. It collects the modules of my freelancer app, and then it writes documentation just by running this unit test. So I can run it, it passes, and then you see that in my target folder there's Spring Modulith docs, and it generates some ASCII doc and plant UML. And with the proper plugins in your IntelliJ, then it just renders some insight in your application, which is really cool. If you change your code, you run the unit test, the documentation is updated. And here you see the modules that I just described, review, bidding, and freelancer, and how they relate. Depends on here means that I cannot compile without you, so bidding cannot compile without freelancer. Review means as a user's relation, and that means I use a Spring Bean of you. So obviously it can also not compile without freelancer, but it's an even stronger relation. And if you scroll below, it shows this from the individual modules. And here it even tells you, well, what bean it references. So that's very nice, but the true power here is this unit test. And again, it's just a single line. This is the same as the documentation. It collects the modules, and then it verifies them. So we can run that test, and it passes. Now, what does it mean that it has passed? It means that there are no circular dependencies between the modules, and there are no violations against access restriction. So to start with these circular dependencies, I can show you what happens if we do have them. Bidding here has a relation to freelancer. Now, we have a bid service and a freelancer service. So suppose I refer to the bid service here. Then we introduce the circular dependency. Now, how will Spring Modulith handle that? The test will fail as expected, but it also gives a very clear message on why it failed. So cycle detected, we have a circular dependency between bidding to freelancer to bidding. And now if as a developer you want to solve that circular dependency, it's quite convenient that it just lists all the dependencies that are responsible for this circular dependency. So here it says the field freelancer in bid has the type freelancer. I can click on that, and that's this one. That's one dependency from bidding to freelancer. On the other end, freelancer module here has in the freelancer service a field bid service of the type bid service, and that's this one. Yeah, the one that I just introduced. So to recall the basics, first a module is a direct subpackage. That's just the convention of Spring Modulith. It has a very nice way of generating documentation dynamically, so you don't have to update it manually. It just run the unit test and it is updated. No circular dependencies between modules. That's another convention of Spring Modulith. Now, access restriction. How does that work? Let me roll this back. And we just talked about, well, the first option for access restriction. I can just quickly show you that here. Review analyzer, it has no public keyword, so the Java compiler helps us with that. If I try to refer it from outside the package, for example here, well, I don't need Spring Modulith for that. Compiler already tells me, well, you cannot do that. So that's very good. But now we've had this case with analyzer service. That's public. And it's public for a reason, because it's used here in the review service. And as you see, the review service is in the same module as analyzer service. So according to Spring Modulith, this usage is okay. But since analyzer service is public, well, I can refer to it from another module as well. No problem. Compiler says no problem. But here the unit test just on my own machine tells me I cannot do that. It says module bidding depends on non-exposed type and analysis analyzer service. So this is an internal package, you cannot use it. It's very nice. This is a way of Spring Modulith to encapsulate your internal packages. Now, of course, it could be that you have a lot of internal packages and you want to override this convention, that you want to encapsulate your internal packages. You want to expose one package. Well, you can do so quite easily by defining a package info and then state that this is a named interface. And the named interface, well, you would be surprised, but it requires just a name. And if it has the name, then it's opened to the world. So if I rerun the test now, it passes because we told Spring Modulith, well, this is just an open package for the rest of the world. Sometimes we want to do it the other way around. So in this case, we opened an internal package to the world, but sometimes we want to restrict us more. We want to forbid some relations. We can do that as well. So for example, here in the bit surface, I can refer to the review surface, which is cool by Java because it's public, and it's also cool by Spring Modulith because it's in the root package, and that is the API package of Spring Modulith. So if I run the test, it just passes. I can use this. But Spring Modulith offers a way to be explicit about our dependencies. Again, in the package info. If we explicitly define our application module, we can say, okay, I want bidding only to allow a dependency to freelancer. And this is everything to define that. If we rerun the test now, it will fail again. And it will tell us why. Bidding depends on module review. And allowed targets only is freelancer. So we cannot do that. Now, if you have a big application and you can see that freelancer maybe is a core module. So we want to allow that for all the other modules to use it. We can do so. So we can remove it here. And, well, let's solve this one. And if we remove it there, you can guess what happens because we still refer to the freelancer. And it complains about that. I refer to the freelancer, but allowed targets are none. But we can define that in a central place. So here we can introduce, let's say, a shared module. And a shared module means this can be used by all other modules. And again, the test passes now because we explicitly stated that freelancer is a module that can be used by all other modules. So this about access restriction. So to recap, package private. If you can use that, that's perfect because, well, the Java compiler will just help us. We don't need Spring Modulith or something. If we need more control, then the convention of Spring Modulith is that an internal package is closed. It's encapsulated, but you can customize it. You can open it to the world, or you can restrict yourself even further. Now, suppose you really like this and you want to use it, as we did with modularity. Now, we started with a code base of, let's say, 200,000 lines. Then, well, there were some big chunks that we could put in a different Maven module, but still we were left with over 100,000 lines. Now, you could imagine what happens if you never took care of any of those conventions of Spring Modulith and you just enable that single line unit test. You can do that. You can just put a dependency in your POM, enable the unit test, but you won't get one failure. You will get an enormous list. Now, what you could do is solve everything and then enable it. But in the meantime, while your code base is alive, and your co-workers or maybe yourself will introduce new features, fix bugs, and maybe introduce new violations there. So in Dutch, you can call that dweilen met de kraan open. It's a bit to mop while the tap is running. And that's not what you want. So ideally, you want to gradually introduce it. So first, you create a module. You think that module is okay. You protect that. And don't take care of the rest. Then you add a second one and a third one until your entire application is okay according to the conventions of Spring Modulith. Now, I will show you 3 ways that can be used to do that. And, well, the last one is the one that worked best for us. And to do so, I will switch to a fat service package branch. Here, and basically this is the same code with one added service package. And in our case, it was including the sub-packages over 100 services. And, well, here are only 2. I can run the unit test here. And it fails because of a circular dependency that includes the service package. Well, of course, it lists all the responsible relations for that, but that's not the thing here. It's just one module that I want to exclude. But still, I want to protect bidding, freelancer, review. If another developer or myself introduces a violation there, I want the test to fail. But I don't want it to fail for this. Now, the first thing that Spring Modulith provides is to create what is called an open module. So again, in the package info, you can create an open module. By default, it's closed. An open module means, well, I don't validate this for circular dependencies, and you can reach my internal packages. So that works for this problem. Why it didn't work for us is because of this. If this service package tries to access the analyzer service, which is an internal package of review, then the test fails. So we could create an open module for this review, but we don't want that. There's nothing wrong with review. So that's the reason that this was not a solution to us. We still want to protect that. So the second option is to hook into the strategy of Spring Modulith on how to detect modules. As I said, the default strategy is that a direct subpackage is a module, but you can hook into that. And I will first demo then how what the modules are validated. And the application modules actually has a very nice toString implementation, because if we rerun the test, well, it fails, of course, because I didn't change anything else, but it also lists the modules of the application. So bidding, freelancer, review, and service. And we want to end up with only review, freelancer, and bidding. Now, next to the strategy of direct subpackages, which is the default, another strategy is shipped, and that is explicitly annotated. And if you use that, then a module is only considered a module if it's explicitly annotated for that. Now, of course, the test passes because we don't have any module, and, well, we can define a module. And in this case, it validates only the bidding module. And this solution could have worked for us. Just add a package info in all the modules that you want to verify. So in this case, bidding, freelancer, and review. The only thing that we didn't like is that we have to add all those things to our production code. And there is a third way, and that is creating a custom strategy for yourself. And that is what we did, because it's, well, not that hard to create one. And let's call it my module detection strategy. And all it needs to do is to implement the application module detection strategy, which only has one method, and that is, well, give me the modules. And if we look into the implementation of this, then we see that it already comes with the direct subpackage and the explicitly annotated ones. And And since our aim was always to end up with the default, because we like the default of direct subpackages, we decided to use that as a base. So application module detection strategy. So if we left it here like this, then we just would have used the default. But since it's a tree, it is a stream, we can filter on it. And this package offers some nice properties to filter on. And get local name is just the name of the module. So bidding or freelancer review or service. And that is a nice key to filter on. So what we did is, well, we created some kind of whitelist. And if that name was on the whitelist, then we considered it a module. So in this case, it was just a set with our modules. Which is freelancer, in this example, review, and bidding. Now the only thing we need to do is to tell Spring Modulith that we want to use this strategy that we just defined ourselves. And we can just do that here. Now if we rerun the test, then it passes, and we see why. Because bidding, freelancer, and review are evaluated. And that's exactly what we want. And so this solution really worked for us. We started just with a single module here, and then we worked on cleaning the second one, added the second, and then when all our direct subpackages were clean modules, then we just throw away this class and the configuration and returned to the default that we still use up till today. So, for gradual introduction, open module is, well, an option, but not really an option for us. Explicitly annotated, then you hook into the strategy and use the other strategy that it comes shipped with. It is an option, but you have to add those package info options to your production code. If you don't want it, you can create a custom strategy. And since it's quite easy to create such a custom strategy, well, that's the one we picked, so we could separate just the production code from this test code. Now, I was talking about, well, cleaning those modules. But then you have to break some dependencies. I will just show you the 3 refactorings that we used most to break those dependencies. So let's just roll this back. Now the first one is the simplest one, and that is just to move code that is on the edge of 2 modules. So for example here, if you want to get the bits for a freelancer, then well, you could create such an endpoint in the freelancer controller, because we want to get the bits for a freelancer. Now this introduces a circular dependency, as you might expect, because we wired the bit service in the freelancer controller. In this case, the first question was, can we move this code? Does it make sense? Well, in this case, yes, the answer is yes, we can move that endpoint to the bit controller as well. So, very simple. And because it's so simple, this was always the first refactoring we tried. But that doesn't always help us, because sometimes code is just in the right place and still it causes problems. For example, if we don't want to get the bits, but we want to set the minimum bit. Now in this case, the feature we want here is to set a minimum bit for a freelancer. So based on the ID, we have a minimum bit in cents. And what it does, well, it gets the freelancer entity, and then, well, it sets the minimum bits, the minimum number of cents for a bit. Then there is some freelancer related logic, and of course if there are bits for that freelancer that are below that, we want to decline it. So we ask the bit service to decline that. Now again, because we use the bit service from the freelancer service, we have the circular dependency. Can we move the code? Well, setting the bit for a minimum bit for a freelancer, it makes sense that we do that in the freelancer service. We have some freelancer related logic here. So moving the code here is not really an option. So the second option we considered, can we, instead of telling services what they should do, can we just tell the world something happens by publishing an event? So in this case, this was the refactored code. And the difference here is that we have the application event publisher. That's just the Spring class instead of the bit service. And here, instead of calling the bit service to do something, we just tell the world that there is a minimum bit event. I don't want to fix this with AI. I don't know, I've had this once before, and the only solution was to reload the project. Yes, don't know. Yeah, let's just create a record. This is the event, and well, we don't need this. So now, instead of just telling the bit service, I want you to do this, well, we just tell the world this happens. And the only thing we need to do is to respond to that event from the bit service. And you can listen to events in various ways, and I will go quickly through those to those different ways of listening to an event. And I think this would probably be the best way. So basically you can just use event listener, and that replaces the method call. Like we had the flow of the program will that this will be run, then the event will be published. So this code is run, and after that this code is run in the same thread, same transaction. So means that if an exception happens here, this code is not reached and this code is rolled back. And if an exception happens here, this code is rolled back. Same transaction, same thread. And that might be what you want. Might be not what you want. So here, for example, if we want to write a log, it listens to the event only in a different thread and not in the transaction of the calling method. So here the flow is, we run this, then an event is published, and one thread does this, the other thread does this. Another one is the transactional event listener, and that one is the one you can use if you only want to process an event if a transaction is committed and not rolled back. So in this case, the flow will be, this code is run, the event is published, this code is run, and if there's no exception and the transaction is committed, then this code is run. For example, if you want to send an email a notification of something that happened. Now this doesn't have a transaction itself, so you can combine it here with a new transaction. And if you combine it with the transactional event listener, you need a new transaction for that. Now this combination is used so often in the event-based Spring Modulith that it's combined in another annotation. If you see the application module listener, it has async, transactional, and transactional event listener. And with that, listener, there are also some extra features, because it could happen that you depend for your correct data that everything is processed. So, for example, this code is processed, the transaction is committed, it's stored to the database, and then here an exception happens. It could lead to an invalid state of your data. Now, Spring Modulith offers an easy way to store the state of those processed events. So it's on restart, it can retry, republish such an event. Also offers a nice way to externalize events if you want to use it by other instances, because these events are just, they live just within the JVM. But you can easily externalize it using Spring Modulith. But just want to mention that, won't go into the detail of that. So this was basically the second refactoring that we used quite often. But now the last one that I want to show you is, for example, if we want to get a freelancer DTO. And well, that's a class, because we want to fill the values here. And now, depending on whether this freelancer has any bits, we follow some logic, and if it doesn't have any bits, then we follow other logic. So let's create this method. Now, again, we created a circular dependency because we used the bit service. Now, is this in the right place? Yeah, I think so. We ask a freelancer DTO in the freelancer service, and we do freelancer specific things. Can we use an event to tell the world? Well, basically not. We don't want to tell the world, we want to ask the world. So we cannot use events for this problem. What you can do is you can invert the dependency. And inverting the dependency means that instead of asking the bit service, we ask an interface that we define in our own module. So, for example, we call that the has bits checker, and that's an interface that we define in our own module. And then we want to ask that our question to that has bits checker interface, and now we got rid of our circular dependency. We don't depend on the bit service anymore, but there's no implementation of it, and that's why it complains here. But we have someone who can answer this question, that it is the bit service. And that's why it's called inverting the dependency, because we started with a dependency from freelancer to bidding here, and we replaced that with an interface, but the interface here is implemented by the bit service. So instead of a dependency from freelancer to bidding, we now have a dependency from bit service to freelancer. But that dependency is totally okay for us. So we inverted the dependency, and by doing that, we solved the circular dependency here. So, to recall break dependencies, first thing to check, can we move the code? Because it's super simple. If not, can we publish the event? Instead of telling services what to do, just tell the world something happens. If we cannot tell the world, but we need to ask the world, we can invert the dependency. Now, to recap, we've seen the power of Spring Modulith in the demo. We see how we can gradually introduce that, and how we can refactor our code to respect the conventions of Spring Modulith. Now, the last thing that I want to talk about is if you want to improve the quality of your code base, either by, well, improving the structure with Spring Modulith or with something else, will that really happen in your company? If you're like the guy on the left, well, probably it won't. replacing the square wheel of the cart with a round wheel is just not worth the effort in the eyes of the two guys pulling the squared cart. But we can apply that to our software as well. Messy code here is the cart with the squared wheels, and some developers are just pulling the cart, and some developers become unhappy. The difference with the picture before is that those developers with the round wheel, they are pulling the cart with the squared wheels as well, but they are aware of a better solution, so they become unhappy. Now, we can see that unhappy developer as a company problem, and that makes a bit sense. Unhappy employees are a company problem, but it's more than that. That messy code is not just the working territory of the developer. It's important for your company. It's often a core pillar, maybe the core business. So maybe this is better. Messy code is a company problem, and well, that causes some developers to be unhappy. But unhappy developers are not the only consequence. More bugs and slower development are consequences as well. But the hard thing here is that, well, unhappy developers as a consequence of messy code, that's easy to spot because, well, those unhappy developers, they just tell you that they are unhappy because the code is a mess. But more bugs and slower development, that's a bit hard to see if you're not a developer. We don't have like a track with clean code and a track with messy code, and we can compare the number of bugs between them and the development time. We just don't have that. But luckily we have a bit more than the gut feeling of developers, because there has been done plenty of research on that. And you can Google on that, but I want to name one, and that's a poll that Stripe did in 2018, where they estimated the cost of dealing with bad code to be $85 billion every year. And that's, well, it's just the time that developers need to spend extra because the code quality is low compared to when the code was clean, and it doesn't even take into account brand damage or something because we have bugs. And well, to put it into perspective, because 85 billion sounds like a lot, but how does that relate? It's like 9% of development time, but it's only the time that it takes extra.
So it's a large number, right? 85 billion, I think you said? Million or billion?
Billion.
So a milliard. And
Miljard in Dutch, yes.
Yeah, so did they also take into account what the cost would have been to refactor all that code? Because if it's like more than 85 billion, then it's like a business case thing.
Yeah, well, they only measured how much time developers are working on refactoring that code, like in this slide. So around 3.5 times more. But yeah, that's a hard question to answer. How much time they should have spent to clean all the mess.
Yeah, you have the sonar number usually that says how many
Yeah.
hours you're behind.
Yeah.
Whatever. I don't know how to calculate it. But,
No, yeah, I'm not aware of that, but and even it varies per company, I think. But the key thing is that it's significant, and still, I think if we don't consider messy code as a company problem, nothing will change there, and it will slow us down. And the situation then is kind of expressed in your company like here. So we take the quick and dirty route, and in the beginning we are quite fast. So customers are very happy, and we are in some kind of colored balloon and champagne drinky party mode. But what we don't notice is that there is a monster in the background, and this monster is drinking some champagne with us. And with every time we take the shortcut, the monster grows and drinks a bit more, and only soon the monster will consume everything that we gain by taking the shortcut. And it won't stop growing there. So from that point on, it will slow us down. And that monster is real, not like you have to look for it, but conceptual. And it's called technical debt. And technical debt, we can repay that by just cleaning our code. Or we can decide not to do that and just leave the code messy. But we have to pay interest. every time that we change our code base to implement a feature or fix a bug, we pay interest with extra time spent on that. And we cannot choose not to do it. We found ourselves confronted with this technical debt monster at Monolith and decided to clear our structure with package encapsulation using Spring Modulith to fight that monster. And well, we didn't regret it until the day of today. Now, to conclude, back to those two guys. We all want to be like the guy on the left, or at least to feel like him. But we have our days like the guy on the right. The proper structure helped us really to have more days like the guy on the left. And I hope if you feel that your code base is becoming big and maybe a bit messy, then, well, I hope you heard at least some things today that you might want to try Spring Modulith to help you to improve the quality of your code and to have more days like the guy on the left. Because I wish you all to have a lot of days like that guy on the left. And well, I could end with these kind words, but I have one very nice opportunity for you to be a Java community contributor. And you can do that by scanning this code and rate my talk. And why are you a Java contributor then? Because I will give this talk at other jugs and even in the conference. And I can be better if I get your feedback. So you can just give 1 to 5 stars for several parts of this talk. And then tomorrow, if somebody asks you in the coffee machine from, what did you do yesterday night? Well, yeah, I've been busy just contributing to the Java community. And that sounds cool. And even if you don't care, you help me or the next audience. Yeah, you can also connect with me. The link also contains my LinkedIn link. You can send me an email. And, well, for now, we have some time for questions, if there are any.
Everybody's busy scanning the code.
Yeah.
How long does it take to? Oh, sorry.
Go ahead.
How long does it take to run the unit test in a big code base? Does it slow down or is it still pretty fast?
Still doable. Still, we have this, well, let's say over 100,000 lines of code. And it takes a bit longer than the one I just showed, but not minutes. It's more in seconds. So okay. That's not a real big issue.
Yeah, one of your first questions was, does anyone think about removing the public keyword from any of their classes?
Uh-huh.
I noticed in your code base, I didn't actually catch it right away, but I think you applied that quite a bit, removing the public keyword. And that's apparently so that you have some compilation time access restriction, right? Can I assume that?
Yeah.
So
yeah, also a new structure like this gives you more possibilities to do so. Because now you have, let's say, your product controller, your product service, your product repository, you have them in the same package. So you don't need to make them public for the sake of them accessing each other.
I guess, if I remember Java correctly, the downside is that you cannot have directories within your module. Is that correct?
Sub-packages.
Yeah.
Yes.
Yeah, you can have sub-packages. But if you want to have inter-sub-package relations,
Yes.
then they have to be public because the packages are different. But
Yeah.
Spring Modulith, that is where Spring Modulith can help you to encapsulate it within a module. And
So, is there any other more compile time way to enable Spring Modulith instead of running the test to have a bit of faster feedback? Is there anything like that?
well, not compile because Java, well, it has the support for package private or not, so there's no compilation support. Project Jigsaw, if you would start from scratch, you might get something that works on the compilation level, but it's a lot harder to introduce, especially in an existing project. You can just gradually introduce that, and I don't think you can do that with the project Jigsaw.
You could write a compiler plugin that runs the stuff that the test runs now. And then
Yeah.
you would need the compiler plugin. So a test integrates nice with your regular workflow.
That's
Yeah, and I think that they are working. I don't know what the current state is of a Spring Modulith plugin for IntelliJ. So it recognizes the conventions, and then IntelliJ will tell you, hey, you are doing stuff that doesn't work. So then it's, well, not the Java compiler, but the effect in IntelliJ is almost the same. So that could be, but it's currently not the case. So, any more questions?
So
Right,
if
John?
I understood correctly, Spring Modulith is a opinionated way of structuring packages and
Yes.
some associated tools that use argument rules to validate that you're not conforming with the opinionated structure.
Yes.
Quite
Yes, it offers just a convention.
Yeah.
And if you don't have to configure everything. It's just a convention, and if you like the
Yeah,
convention,
probably
then
you
it
slap
works.
it, in your palm and you're good to go, right?
That's exactly, yeah. You just put it in your palm, and that second, or that one line unit test and that one line documentation thing, you can just add it and it works.
Documentation generator as well, then.
Yeah.
Mostly about package structure and dependencies, I guess, right?
Yeah, the module is here the thing, so it's the direct subpackage from the root,
Yeah.
and not the subpackages within that module.
You mentioned the async annotation together with the event listener, and what was the third one?
A transactional event listener?
Yeah, and and I think these three are actually in the normal Spring boot, part of normal Spring boot without Modulith. Is it true? But
Yeah.
only the combination of the three, I think it was part of Modulith. Is
That's
it
correct. The
Okay.
combination is from Spring Modulith,
Yeah, okay.
and that is
It's
because
basically the combines of the three which are already available in
yes,
Yeah.
and it really wants you to be more event based, and this combination of the three is used a lot together. So they did one, and also the auto retry on failed events that works with that application module listener.
And you mentioned something about the events being only in the runtime, of course, but it's also possible to have them, I don't know, put somewhere on.
Yes, the events here are just free
Queue or-
events, so they run in the JVM, but you can add just an annotation to that minimum bit event that I created to externalize it, and then you can, externalize it using SQS or something.
Ah, okay.
And that's just, you pull in just another dependency of Spring Modulith,
Yeah.
and then basically what it does under the hood is that it listens to those events within the JVM, and then it pushes them to, just the dependency that you are.
You've configured somewhere.
Yes.
Yeah.
Exactly that.
Cool. Interesting.
Yeah. So,
Okay.
if no more questions, we can talk around the drink and